Welcome, everyone. Thank you for attending this session. In this session, we have Jinjin Zhao, Senior Applied Scientist at Amazon.com, presenting the interdisciplinary nature of human learning and techniques for understanding and improving how humans learn. Jinjin, please set your timer and get ready. Off to you.
Great. Thank you, Mungyuan. All right, so hi, everyone. Welcome to my session. Nice to meet you through the attendee list. Feel free to use the chat to meet each other if you haven't, and leave questions in the Q&A. I want to make it fun and useful to you, so please help me on that by letting me know how you think. And if it is confusing, let me know where and when, and I'd love to address that at the end. And I'll make sure we have enough time to discuss either during this session or after. Okay, let's get started. So human learning and improving human learning is a huge topic. We started learning as a baby and we continue learning throughout the life. That is how humans progress, evolve generation by generation. However, even we are experiencing it every day and hour, and even now, we don't think much or learn much about it. Of course, this session is an exception. We're just focused on thinking and learning about human learning. But the truth is we're not yet able to come up with a comprehensive understanding of what human learning is and what we can do to improve it. And there's no doubt that understanding learning is important because what we learn, how we learn constitutes who we are, what we want, how fulfilling our lives are. And also learning is complicated. It is complicated because of 4 aspects, in my opinion. The first one is there's no ground truth of it. The ground truth of how we can learn in the most effective way for each of us. We learn by doing, by failing, by reflecting, and sometimes through others' storytelling. In short, we learn through observation of ourselves and others. And we have no direct access to the covert mental process, the brain. As we all know, brain is the most mysterious organ researchers have been exploring since humans discovered that we are different from other species. Second aspect is learning is...
Are you advancing your slides? We don't see the advance your...
Yeah. I'm setting up the context, so
okay. Sorry.
I'm on the right slide. Yeah. The second aspect is learning is different for each individual since everyone has a personalized model of learning and a unique view of what learning is. Third one is the education system has treated us all the same in throwing us knowledge that they think we should develop when we were a kid. And they didn't consider what I need and how and when I want to learn it. Sometimes the way we got trained adds difficulty when we want to learn something new because we have to unlearn things first. The fourth point is metacognitive skills were not built, but should have been developed as we were a kid. Metacognitive skills is the skill learning how to learn, learning how I should learn. And studies have shown that kids who have developed such skill when they are 4 to 8 years, they outperform in their studies, their career, 10 to 15 years later. And there's no teaching on how metacognitives how important it is, and there's no teaching on those skills at all. Briefly, no ground truth. It is diverse. We need to unlearn things first, and we miss the great opportunity for developing the metacognitive skill. That makes human learning interesting, and we are going to make an attempt to discuss it today. I'll be talking about the research work I've been doing in the past 2 years on human learning through applications in a corporate setting. And I'll decouple the huge topic into subtopics and share some findings around how we can use machine learning, cognitive sciences, learning sciences to help understand what it is and how we can improve it. It is perfectly okay if you have a great deal of questions in your mind at this moment, and hopefully you'll get even more question marks at the end of this talk, the questions generated by your curiosity. All right, let's step back and think about what is learning. What comes to your minds when you think about human learning? So here's what my take on it. Reading in a library, assignment after assignment, discussing with group in a classroom, or learning through online, or through all kinds of experiences you came across, like these events. meetups. Today we will be focusing on online learning, through which learning experiences can be delivered to individuals at scale through and also with curated design. Okay, and what comes to your mind when you think of online learning then? So, in my opinion, based on my experiences, I will first select platform, Coursera, online classrooms from universities, and then pick a course I'm interested, NLP, computer vision, whatever, deep learning 231, and you follow whatever is presented to you, read the content, answer those embedded quiz, assessment, session after session, and take the final assignment before you get some form of certificate. So here's my question. How comfortable are you in such a learning experience? Do you like it? How much you like it? Is there anything you think could be improved for you? And here are the things I have been wondering. First, what does the certificate mean? Actually, what does a degree mean, right? And how much knowledge I've learned from these learning experiences that I can apply directly into my projects? And what is the gap for me to deliver an end-to-end project? Should I spend more time? Should I spend time on this assignment? Is it helping to deliver that end-to-end project? If not, what are the alternatives that is worth my energy and time? In short, we as a human always wanted to be validated, but only validated in the right approach that is helping achieve our goals. Are those assignments the ones through which my skills can be validated for my project? We not only want to be validated, but also want it to be understood in general and also in learning context. We want to be understood by the tutorial system, by the algorithms behind the screen. Is that feedback for me, not for everyone, because I'm different? So those are just two examples of the questions we can and we should have when we are learning through an online platform. Today, we will be discussing some state-of-the-art models, frameworks, techniques that can help us deliver a more effective and efficient learning experiences to learners, an experience that understands you and provides what you need. So that as a learner, we can not only develop the desired skills, but also gradually develop the metacognitive skills, as mentioned. So we have focused on learners only, but in this ecosystem, we have other players like learning designers and learning scientists and practitioners. So let's also think about what is each player's interest. As a learner, we've talked about it. I want to know where I am, the knowledge state, and what is the path forward, and what I can do or how I can demonstrate the skill I have developed to feel good about myself, right? And as a learning designer who create those learning experiences, they want to discover what is working and what is not for my audience, the learners in a learning experience, and how I can improve the design for whom in developing what skills, and how I can better structure the knowledge so that I can observe easily where and when the learner got stuck, and how I can provide feedback to help them out. As a research scientist, I want to discover what insights can help learners to understand where they are, how to proceed, how they can demonstrate, and also the insights that can help designers to understand how effective the experiences are and where to improve and how. And also want to find the findings to augment learning science theory and practices to find the truth of learning. So here's the list of subtopics. I will just get you into the story, and after that, after your mind filled with question marks, and I will stop, and hoping you will start thinking about learning every time you learn. So the first topic is student model of learning. What is it? A student model of learning is a model that estimates where the student is in the learning experience, in learning something. Where refers to the knowledge state. For instance, 100% mastered or 60% mastered on a given subject. Why do we need knowledge state estimation? First, knowing where we are is the first step in deciding how to proceed. And second, having the access to where we are at each step, we can gradually develop the sense of how we learn, the metacognitive skills. And knowledge tracing is not easy because learning is a covert mental exercise, right? But there should be ways we can observe how the brain is functioning. There are different ways to observe that. Brain imaging is for sure a solution, and attaching sensors to a body to collect the biological signals in addition to brain imaging is another. There's cutting-edge research around those notions, and for today, we're talking about using quiz, formative assessments to estimate the knowledge state. For instance, using a multi-choice question, single choice, matching, sorting, quiz, even an open-ended constructive response question to understand and evaluate whether you're good to move on. And in order to ensure the system is able to make a confident and accurate estimation, usually you will be provided with a minimum number of exercises to demonstrate that you are not guessing, not cheating, right? And the minimum number of exercises is decided by the complexity of the skill. And for each exercise, you can always take as many attempts as you need to practice. And you learn from those attempts because there will be feedback provided to you as you fail on a particular attempt on a question. So after you have practiced all that exercises, the system has collected your sequential behavior, and some mathematical model will take that sequential input to estimate your knowledge state. That model is called the knowledge tracing model. And knowledge tracing is the task to look at the sequential data and estimate where you are, but based on what? Because we don't have access to the ground truth. Thus, define what is the proxy of the truth. Why that proxy is the first subtask in conducting a knowledge tracing task. But sadly, there isn't much work around how to find a better proxy. Anyway, after defining the truth proxy, how to make the algorithm as accurate, reliable, interpretable as possible is the second set of subtasks. I've made some effort on building a student model. Things will get a little bit technical, so try to type in questions if you feel it confusing, okay? First, I try to define the truth proxy as the average correctness of the successive n attempts. Let's say you failed on the current attempt, on the current assessment, but you are able to constantly succeed in the following 5 attempts on the successive assignments. That indicates you, even you failed, you've learned something so that you're able to solve the successive problems. So your current knowledge state will be estimated, let's say 90%, close to proficient. Let's just assume 5 is the statistical number of evidence you need to demonstrate that skill. People usually only look at the next attempt correctness, the only next attempt as the truth. And I feel not that comfortable about it because we need a consistent signal to be able to estimate confidently for some of the skills. That's why I propose to look forward with successive n attempts. The n needs to be defined by the course designer based on the type of skill and the complexity of the skill. So in this figure, all the rest attempts correctness is averaged, just to illustrate the idea. So as a result, with a few steps forward looking, we can observe a clear trajectory of both actual and estimate knowledge state. And the accuracy of the estimation is pretty good. The blue line is the estimate, the yellow line is the actual. So here the actual means the proxy we defined at the beginning, okay? In comparison, if we only use the first attempt correctness as the proxy, there's almost no pattern can be observed. Your answer is either right or wrong is binary, and the actual line is jumping up and down between 0 and 1. So how can you expect an algorithm to predict accurately and confidently by feeding it with randomness? That's why the blue line just gave up at around 0.7 accuracy and stopped looking for a better solution. So few step forward looking is a neat truth proxy to me. There are still questions unanswered. So we average the correctness of the successive n attempts or use some statistical models such as regression to better approximate what is happening in the brain and how to demonstrate which makes more sense and also what makes more sense in what context. Another research work I did is modeling the behavior at a attempt level other than the assessment level. So practically in most of the online learning tutoring systems, people aggregate attempts into assessment level and model from there. And the problem with that is the details at attempt level are sadly distinct. And attempt level tells us how the learner is making progress along and for the same assessment. That's why what I did is to enhance the Bayesian knowledge tracing model with temp info and a little bit info for Bayesian knowledge tracing. It is a hidden Markov model that models the probability of a learner guessing, flipping, transitioning, and the knowledge state. So we also did the minimum number of exercises opportunity estimate to ensure the model produces reliable estimation. The value is it offers insight to our designers about how many assessments they need to create for that particular skill so that our learners will have enough opportunities to practice and demonstrate what they've learned. We have 2 articles about them last year at ACM Learning at Scale. Feel free to check them out. Let's jump to the second topic, which is the personalized adaptive learning. Personalized learning is not new, and people have different definitions for it. I define it as a tailored learning experience with accurate knowledge estimation and targeted recommendation on the next learning activity. When I say accurate, I mean it is accurate to you, not accurate to an average learner. Targeted recommendation means a recommendation for you based on where you have been, where you are at, and what you aim for. As we just talked about the knowledge state estimation, think about what we usually do in a real life learning experience, not an online one. So in order to figure out where we possibly are, we might go to experienced people or mentors to help us figure out where we are by describing them what we want, what we have done, and what we are struggling with. And since they are more experienced or they have gone through similar experiences, they might provide you an estimate on where you probably are and what you could probably try as the next step. And if they share some background knowledge with you or some past experiences with you, that'll be awesome because they can know you better in that way. So inspired by this thought, people who are experienced would probably know where you are. We would naturally start to think, why not let machine do the job for us? The job refers to find the people who are already experienced and similar to you, look at their trajectory, and then look at your trajectory and do an estimate on where you probably are in this journey and what you could try based on what they've done up to their then current status. The actions they've taken that makes them proficient, right? So we can further optimize the learning trajectory by looking at the most efficient path forward for you as well. Yes, that is the solution. And the good thing is it not only scales, but also more practical and accurate in some use cases, because in real life, a mentor is not always easy to find, connect, and the estimation from a mentor is just a perspective from someone. It might be biased, and there's no way to see if it is biased. And what machine can do is to scan all the experiences from others, filter what kind of people's trajectory might be of help, and and calculate your current status and the next steps based on info from others. To me, it is more transparent and much closer to the truth, and you also have some level of control over it. So why not? But we need to be prudent when we design algorithms. What do you mean by experienced? How experienced that person needs to be, and whether the evidence is relevant and convincing. Part of the reason actually I love science is because every step I take will bring me closer to the truth. It also means most of the time we don't have a direct answer to those questions. And that is why we need to do experiments to discover the truth, or at least to collect some evidence to support the unknown truth, or even just to prove something's wrong, something's not working. So in this application, we follow the same philosophy of doing science. That is, we first define the algorithm and we test it out. And the algorithm we came up with, we use the we use the similarity measure to define who are similar to you and who have been proficient in that skill. You can look through the steps and then look at what are the most common next steps and use that as a recommendation for you. And we've tested that in our learning platform, but sadly, I'm not allowed to share that info right now. But what I can say, how to define who are similar to you, or what attributes contribute to the similarity, the similar and experienced people from which you can learn eventually. In order to do that, I incorporate learner attributes to augment the learner profile and hope a machine can help me figure out what attributes really matter in what context. So a learner profile would include categorical features such as job tenure, skill, job info, and also the learning patterns, the learning pace, the learning style. And the machine will take everything in and do its job we ask it to do. And part of the result which I can share, we found that at the beginning of a learning experience, because we don't have enough data points for this particular learning experience for that particular learner, the categorical attributes play a more important role in measuring the similarity. But as the system collects more data about the learning experience about that person, then the learning pace, the style contributes more in finding the similar experienced learners. And some of the detailed implementation is listed in this paper. If you're interested, check it out. And we definitely use the attention layer to define the similarity and a generative modeling tool called the variational inference to embed attributes, just for information. All right, let's get into the third one, the target feedback generation and insights. One big expectation we have for tutoring system is that they can generate feedback to a learner, like a coach, a teaching assistant. And there are two benefits of such feature. One is learners can receive feedback, guidance at any time where they need it. Another is it frees up time for teachers to focus on other important tasks in teaching. So what has been extensively looked at is how to conduct auto-grading or design a one-one mapping feedback beforehand for any possible situation so that feedback can be surfaced as needed. Auto-grading is helpful, but that is not enough. We need feedback, not only a score. Tell me how I can improve other than how bad I did, right? And for those multi-choice questions, single-choice question, a predefined feedback is possible. For instance, if you pick this distractor, then work on this concept. But when it comes to open-ended, constructive response questions, then it becomes difficult because the answer from the learner is no longer a predefined one. And we need ability to understand what the learner is trying to communicate before we can offer any help. Thus, in this topic, we will be focusing on generating targeted feedback for constructive response question activity. It is an NLP pipeline. It is an NLP application, and the solution is an NLP pipeline. And the difficulty, as I mentioned, is how to extract those semantics from free-form text and matches to what is expected, and then derive the knowledge gap and provide feedback based on the knowledge gap. Especially when there are more than one grading points to be measured, things becomes more interesting. And in this example, we have 5 grading points that we are expecting from a learner, and we aim to provide the guidance based on what they've mastered and what they haven't out of these 5 points for this activity. So, you know, NLP application is always interesting. It's always a pipeline you can build. And the solution we came up with and works well is as follows. We first augment learner answer and model answer into chunks, and then extract the semantics from both answers. After that, we derive what is answered correctly, what is not, and finally we provide feedback based on what is not answered correctly yet, and because that's the knowledge gap or the misconception where the learner needs more practice. A bit more detail on the approach. In both segmentation and semantic extraction, we compare graph-based, statistical-based, and semantic-based approaches, the transformer, to see what is working at when and what is not working and why. There are quite few interesting findings actually in this paper. Please check it out if you're interested. And the paper is luckily selected as the best paper in triple AI education this year. All right, let's get into the fourth topic, which is conversational agents. It's an interesting one. As we know, there's a big concern for the online learning, that is lack of face-to-face or in-person practice opportunities, even a virtual one, a virtual discussion, not a pre-recording like this one. And in-person practice is important, especially when developing skills that is to be applied in a conversation, right? Such as a communication skill or an interviewing skill. On the other hand, we have voice assistant living in our home, and we want to see how, let's say, Alexa can help in a learning context. Not just carry on conversations talking about the weather or some random chit chat. We want Alexa can support us both emotionally and intellectually. I explored a bit around what role Alexa can play in a learning experience. And there are two roles I designed for her. One is a peer role, another is a coach role. So as a peer, Alexa is expected to understand what the learner is trying to communicating and then respond with her own wit. As a coach, Alexa is expected to whisper to the learner on what needs to be improved. So in order to support these two roles, I developed a conversation engine that can be configured as needed. So in the framework, we have modules of voice recognition as the first step, and then scenario identification and branching, and then conversation status tracker, natural language understanding, nudging with hints, and recording, storing into the cloud. In order to make the conversation, a designer needs to configure the conversation flow, design how Alexa would respond if one is able to behave expectedly. If one is not able to, then what kind of hints to provide. And also configure what are the different scenarios and branches of a conversation to make the conversation natural and complete. We implement real application to support developing an interviewing skill, and hundreds of learners at Amazon are enrolled in that pilot. And as a result, learners who have practiced with such activity outperform others by 10%, measured by the first attempt correctness, a well-adopted measure. And personally, I really like Alexa the most when she whispers, because that shows her kindness when I'm not doing a good job. All right, I hope I'm still having your attention. This is the last one, and it's my favorite one. It's about skill model of learning. So at the beginning, we've talked about the student model of learning, that is about knowledge state estimation. Now we're going to talk about the skill model of learning. A skill model of learning is a cognitive model of learning. It's a computational representation of how people think about and develop the knowledge within a subject area. For instance, very broadly, as a data scientist, as you perform a data analysis task, there are different skills, right, around data pre-processing, building a neural net, define a metric, and studying a use case. Usually the use case study comes after you have mastered all the other stepwise skills. And skill model is expected to be fine-grained. So it will decouple the data pre-processing into cleaning statistical analysis. And for the statistical analysis, it will further be decoupled into different ways, the skills we need to do a statistical analysis. The basic concepts like central limit theorem, maximum likelihood estimation, those things. And the cognitive model of learning tries to structure the skill within a subject area so that designers can design a more accurate or clearly structured experience. More clearly structured experience means each step you take, you know the purpose and you know the desired outcome. The second is the sequence of the learning steps fit into how usually learning happens. So as a result, learners can learn more efficiently and then naturally learn in the flow. And at the same time, when there's something learners are struggling with, we can easily identify what it is because we know the purpose of that particular piece of design so that we can offer you help. It's very interesting, it's very important, and also very difficult to construct knowledge, such a skill model because we don't have the ground truth. So all the best we can do is to augment the human intelligence with artificial intelligence and come up with such a model of learning. And it works as follows. Learning designers conduct cognitive task analysis or think aloud protocols with subject matter experts and unpack the knowledge into skill models. An initial skill model is born from human intelligence. And after the course is launched, the learners start engaging. We applying algorithm to discover the skill model based on the learning interaction data. And the third step is to provide discover the skill model to designers so that designers, they can take a look at the perspective from data and revisit the course design and incorporate the useful insights into the revisions of the course. So regarding the algorithm in step 2, we use the generative model that follows Bayesian rules, that is to learn and represent the latent factors of the skill, and then a Gaussian mixture model is used to discover the skill model based on the factors. So I'm trying to make it sound simple and easy, but honestly, when things come to brain and how brain works, it's always challenging and a lot more fun work to be done. All right, so I'm right on time. There's still a lot more interesting topic going on, the co-star modeling, ethics, human learning, NLP applications to support learning and design. We don't have time and we won't be able to talk about all those things. So that's all. That's all for today. Thanks for staying my session. I think we can start the Q&A session if there's any.
Yeah, Jinjin, can you see the questions in the Q&A tab? Feel free to go ahead and answer them.
Yes, the first one, Samantha Evans from, can you speak a little more about how performance like students input and sport in guidance work also? So the first one is around auto grading. Is that correct? How we want to evaluate? Please speak up. Is my understanding correct? How we measure the answer. So the work I did is for those open-ended response questions, which is usually we have a model answer designed by the designers. Like the case I shared, there are 5 grading points. So we try to segment the input from learner and try to do a match. Oh, I just realized they were not able to speak up here. Okay, so how accurate is this tool? There's no similar work like it's a pretty new area, I'd like to say, especially when it comes to there are more than one grading points. So how you structure the learner answer and match to the expected one, the comparison is really interesting. So the accuracy we got is around 80% using the transformer based, which is also contextualized using the domain corpus. What do you mean? I think maybe we can discuss offline if you have any follow-ups. Let me go to the second one. Do you think these things can be predicting state of humans? Language acquisition. Do you mean by learning language? I definitely, because language acquisition is a very standard task we always play with. Those techniques currently are applied to solve those conceptual knowledge learning or procedural knowledge learning. We're doing both, and definitely language acquisition is a mix of these two. Yes. The third one, do you use any learning bias What do you mean by learning bias? That is something I'm not that clear. Yeah, I think I'm not able to answer.
That's satanic. If you want to just type in the follow-up questions so that we can, so Jinjin can know what exactly do you mean. There is a lag, so it might be a while before it comes up.
The assumptions of because I talked about so many things, so I'm a little bit lost on which topic you're trying to understand more. So yeah, but we can definitely take it offline if you like. We can connect, and happy to answer any questions you have.
Okay,
we have 3 more minutes.
Are there more questions from the audience? I will share Jinjin's email right now in the chat. So if you guys want to follow up directly with her on email or on LinkedIn, feel free to.
And if I'm allowed, we are hiring. Yeah. And I definitely believe this is a really interesting domain to devote your energy in. I've been in on this for more than 2 years, and I just cannot stop doing those research publications. Yeah, I really hope more people can join us doing this together, even not through like working together, right? We can still do it offline if anyone is interested.
Awesome. If you okay, so I will just ask the attendees who are looking for jobs, for example, interested in this opportunity, reach out to Jinjin on LinkedIn, and you guys can get connected there. Okay, then that concludes the session. Thank you for the amazing talk, and thank you everyone for attending. Look forward to seeing you in other parts of the conversation.